What's up, everybody? Welcome back to another live stream from Scalar Learning. And it is Sunday. It is that time. We're doing more SAT math. So without further ado, let's get into it. Today we are working on nonlinear equation graphs, level 3. And you know what? I'm noticing that, actually, I think these have all been level 4, to be honest. I think it's just set me at level 4, and we're doing like the hardest problems. But either way, here we go. Let's do it. The function y equals g of x, where g of x equals this guy's graph in the xy plane, which is a true statement. Okay, first of all, whoa, what is this? This is a calculator question, but a negative x. So hold on, I have to think about this for a second. This would look like, I'll kind of show you what it would break down, and then we'll graph it on Desmo so I can even show you to make sure. So look, as x increases, this is really tricky. This is actually increasing. I had to think about this for a second. So look, I can rewrite 3 to the negative x plus 2. I can rewrite this. Since it's a negative exponent, I can turn it to a positive exponent as long as I flip this and take the reciprocal. So this becomes actually 2 over 1, or 2 to the x plus 2. So this is the final function. So this is a straight up exponential function. Now we can plot a couple points to figure out what it would look like. Like for example, when x equals 0, this would be 2 to the 0th power, which is 1, times 3, which is 3, plus 2, which is 5. So we could say at 0, it's 5. When this is negative 1, it's going to be half times this is 1.5 plus 2 is 3.5. So this is 3. And let's say this is 1. So then there would be a point there, and so on. And then it's going to probably increase pretty fast. So when it's 1, it's 2 to the 1, which is 2, times 3 is 6, 8. So 1, it's like 8. And so on. So my guess is it's going to look something like this. All right. And there we go. It is definitely always increasing. This is just this will slowly burn down to, well, actually, no, hold on. This won't go below 2. Let me just make it a little more accurate. This is good. And then it's going to like kind of taper off at 2. And then it'll go on to infinity. The y-intercept of the graph of the function is 0, 2. No, I said the y-intercept was 0, 5. So b is out. The x-intercept of the graph is no. There is no x-intercept. It will never hit x. The function g is symmetric. No, you can see it's clearly not symmetric. All right. And there you go. Oh, and they even graphed it. We called the graph 1/2 x modeled exponential decay. So that's if there is a 1/2. But in this case, it takes a long time for them to do all this. Oh, okay. So they considered this like a what's it called? A flip across the y-axis. So that's how they looked at it, a series of transformations and shifts, and that's fine. I feel like my way was a little easier to break it down, but there's the correct graph, like that. All right, next question. Pretty hard question, I'd say. Next, rational function is graphed. Which of the following functions could be represented by the graph? Wow. Like I said many times, I've never seen anything like this on the SAT, where you're trying to figure out what graph matches up to one of these functions, because it's a little bit more advanced. Oops. Oh, I see. Okay. So here's the way that I'm going to approach it. What I see is I see a horizontal asymptote at x equals 1. I'm sorry, y equals 1. More importantly, I see a vertical asymptote at x equals 3. So what that tells me is, negative 3. So what that tells me is that I need to have in the denominator x plus 3, because vertical asymptote is going to occur where the denominator actually goes to 0. And the only way it's going to go to 0 at -3 is if I have x plus 3 in the denominator. So I think I looked over here and I see these two functions have x plus 3. So a is out. Let me write a thing like this. A is out and b is out. So it's either this one, x minus 1 or x plus 1. Now there's a number of ways I could deduce which one is correct. I mean, we could do a little bit of plug and chug. And let's see, what's a fast way? 0, 1. Oh yeah, here we go. The y-intercept. So for example, I can see that there's a y-intercept at 1. Now, if I plug 1 into this function, I get 2 over 4, which is 1/2. That doesn't work. But if I plug in 1 in here, I get 1 minus 1 over 1 plus 3, which becomes 0 over 4, which is 0. And that's what we wanted. So when x equals 1, y equals 0, the function equals 0 in this one. So it's actually, this is our answer, which is C. Next, which of the following shows the graph of the equation, blah, blah, blah. All right. Again, let's use the same strategy. So I want to know when this is going to 0 in the denominator. The top will give me my y-intercept. So the top goes to 0 when x equals -4. So I'm going to have my y-intercept at -4, 0. That helps. And then I'm going to have the denominator, x minus 2x minus 5. When that goes to 0, we're going to have an asymptote. So I'm going to add 5 to both sides and then divide by 2. So my asymptote is 5x equals 5 over 2, or 2.5. Okay. This is the wrong y-intercept. Wait, this is also the wrong... Oh, I'm sorry. Yeah, -4. This is also the wrong y-intercept. It should be there. That looks like the right y-intercept. Well, it has to be this one. And we can just double check that the asymptote's correct too. It looks like it's about right. 2.5. Close enough. All these other ones, the asymptotes are off, way off. There we go. Boom, next. Y minus 3 equals 1/3 x, blah, blah, blah. Okay, so we need to solve the system of equations. Basically, they want to know which one has graphed it correctly. First of all, let me isolate, this is a circle, but let me isolate this one first. It's y equals 1/3 to the x plus 3. So this is, now we have a fraction to a variable exponent, which means this is a what's called a decay function. And I can graph some critical points just to give you an idea of what it looks like. All right. First of all, I know when x equals 0, this goes to 1. 1 plus 3 is 4. So when x equals 0, it's at 4. When x equals 1, it's at 3 1/3. Let's say around here. When x equals 2, it's 3 1/9. So you can see it's like getting closer and closer to 3. Okay. And then this would like shoot up then as this goes negative, because it becomes -1, then this is 3 plus 3 is 6, -2, so on and so forth. So that's roughly what this looks like. Now this is a circle, okay? A circle is x minus h squared plus y minus k squared equals r squared, which means the center is at hk. So where's my center? My center is at 3, 2, so 3, 2. And it has a radius of whatever the square root of this number is, which is 4. So 1, 2, 3, 4. 2, 3, 4. 1, 2, 3, 4. 4. You don't need to do all of this to solve it. I'm just giving you an idea. Like, it should be something like that. Okay. Now let's take a look and see what we got. So first of all, this is not exponential decay, so this is wrong, right? And the circle's way off too. It's not in the right spot. This circle looks to be in the right spot. Hold on. And the function looks right. Actually, b looks right, but Let me, once again, what did I say the center was? 3, 2. Hold on. 3, 2. Yeah, that looks pretty good. And then a radius of 4. Yeah, it's probably B. This one is wrong. Again, I told you it's going to increase as we go off this way, not decrease like that. And this one's totally wrong too. So I think we're good with B. Last question. All right, the function with that equation is graphed in the xy plane. The graphs only to relative extrema are relative maximum at this, and relative minimum here, relative maximum. Okay. This function looks like this. All right, normally something x cubed is the other way, like that, but because that first one is negative, it's going to go in this pattern. So they're saying basically the minimum, this is my relative minimum. It's like where you have this little dip. It's going to be at -2, -32. And this one up here is the relative maximum is going to be at 232, like that. Okay. And then check it out. We're talking about increasing and decreasing. So decreasing is where the slope is negative. So all of this is decreasing up to this point. And then it's again decreasing here. And the increasing part is right here. Okay, it's going up. And that simple graph, that should be enough. All right, so here we go. The function is increasing. No. It's increasing greater than -2 and less than 2. Function is decreasing when x is less than -2. Yes, right? That's decreasing. Increasing when it's -2 and 2, right in between here. And decreasing when x is greater than 2. And that's what we put here. Boom. So it's got to be B. And that's it. All right. These are hard. These are difficult problems. I've never seen anything like this complicated on the real SAT. I could suppose I could see some of these on there. But again, I'm just trying to reiterate the fact that I don't want you to go crazy over these level 4 problems because they just don't seem like they fit on what I'm used to seeing on real SAT problems when I take the test or on the College Board practice test and so on. So it is what it is. All right, that is it for today's live stream. Hope that was helpful. If you did like it and enjoy it and find it useful, please click the like button. I really appreciate it. And of course, subscribe if you haven't done so yet to make sure you get more up-to-date information on everything you need for math preparedness on these standardized tests. Last but not least, we got Friday Minute Study Tips coming out every Friday. So make sure to check in for those, subscribe for those, because those have been really cool. I've been finding some great, useful information that I've been able to relay to everybody. That's it. Hope you have a great long weekend. Thank you guys so much for joining, and I'll see you all next time. Take it easy.